Hello viewers and welcome to the lesson. This is section 2 of the color paper. You can go through the videos and you'll find section 1. I've already uploaded all the questions in section 1. Also remember to go through the description of the video. That is where you get the link, download the question paper. Now let's go to question 17. These are questions on surveying techniques. Before I go to that, remember in section 2, you're supposed to answer only 5 questions. So when you're choosing the questions, ensure that you choose the best 5 that you are able to do. Now, question 17. The table below shows measurements in meters of sisal plantation. The baseline is XY, 600 meters. So you have the table there showing the offsets. Part A of the question, using a scale of 1 centimeter represents 50 meters. Draw an accurate scale diagram to represent the area of the sisal plantation. So you will allow me to slightly adjust this baseline because I've zoomed my page here, and by zooming, I've affected the length of this line. So it is not in the right measurement. So you're supposed to have the baseline as 600 meters. It is here 600 meters. And when you use the scale, 1 centimeter to represent 50 meters. So 600 meters will be 12 centimeters. So just ensure that this is 12 centimeters. In your case, because using the hard copy, you may not have issues. So I'll adjust this. It is quite big. I noted it is quite big. So I'll go by my measurements here. So this one, so this will be 12. So 12 will be around there. So 12 will be around there. So let me use that as Y. So Y, I've changed the value of Y. So Y will be here and not here. Now, let's go to the table. When you go to the table, you have offsets that are to the right. This one will go below the baseline. So the offsets that are to the right, all these will go below. And then the offsets to the right will go above the baseline. So from X, we have 150 meters. So remember, we're using the scale. 1 centimeter represents 50 meters. So you have to divide this one by 50 to have the centimeters. So 150. So from X, 150 meters is 3. This will be 3 centimeters. So 3 centimeters. So let me take that measurement of 3 centimeters. 3 centimeters. So from X, 3 centimeters. Let me use the ruler. So 3 centimeters will be there. So this is where we have 3 centimeters. It's good to indicate these. So this is 3 centimeters, or what we call 150 meters, because we're using the scale. Then from there, we said the offsets to the left will go above. So 175 to P, 175. So 175, how many centimeters am I going to measure there? 175 divided by 50. So that one I have to measure 3.5. 3.5. So 3.5. Sorry. So 3.5. So 3.5 is around that point. So this is 3.5, as you can see. So from 0 here, 3.5 is there. So you draw a line. So you'll draw a line. So up that point. So that is 3.5. So this is 3.5. So this one, 3.5 centimeters. So we have P here. So that is why you have P. Then from there, from 150 to 200, that is a difference of 50. So from this point here, we're going to measure 50. So 50 is exactly 1 centimeter. 50 is exactly 1 centimeter. So from 150 to, so this is how you measure it. So from here, you can see, from 150 to 200, so 150 is up to here. So 200, you can see it is a different, you add 50. So from 150, that is 1 centimeter. So this is the point where I will have to be here. Sorry, let me mark it properly to be there. So there we have it. So this is 50. So this is a 50 meters, which is 1 centimeter. So from there, we go to 200. So up to there, we go to the next offset. So 200 is there. So 200 is at this point. So you go to the next offset, that is 150 to T, 150 to T. So to the right, so this one will go below. So you're going to measure 150 divided by 50, that is 3 centimeters. So 3 centimeters below. So 3 centimeters. So 3 centimeters below. 3 centimeters up that point. So 3 centimeters there. So from 0. So this is 3 centimeters or 150 meters. We proceed the next offset. So from 200 to 325. So that is a difference of, so what are we supposed to add to 200 to get to 325? That is exactly 125. So just take 325 subtract 200, that is 125. So what is 125? Using the scale 125 divided by 50. So we shall measure 2.5 centimeters. So 2.5 centimeters. So from 200, we measure 2.5. So it is from this point now, is where you have 200. You measure 2.5, measure 2.5. So from this point here, so 2.5 will be exactly there. So that is why you have 2.5. So this is 2.5 centimeters, which is the same as 125 meters. 125 meters. Then from there, now we are at 325. So we measure the next offset 150 to Q. 150 to Q, 150 to Q. And you can see the ones that are to the left, they are going above. So 150 is, this 150 divided by 50, that will give 3 centimeters. So we measure 3 centimeters up, 3 centimeters up or above that line, the baseline. So 3 centimeters, so 3 centimeters, there it is, there it is. So 3 centimeters, quite big, supposed to be up to that point. So now this is the point that we need. That is, we go to, that will be Q. So this will be Q, and we've measured 3 centimeters, which is the same as 150 meters. Then from there we have, from now 325, we go to 500. From 325, we go to 500. So what are we supposed to add? From 325, so we simply get 500, subtract 325. To know what are we going to add from to 325 to get 500. So that is a difference of 175. So 175. So 175 divided by 50, I'll have to measure 3.5. That will be 3.5. So we measure 3.5. Now from this point here, we measure 3.5. So 3.5 is there. There it is. So this is 3.5 centimeters, which is the same as, that is 175 meters. Hope you've seen how I've done that. So from 325 to 500, you're adding 175. So 325 plus 175, you got to 500. So now at these 500 to the right, you'll go 100 to S, 100 to S. So 100 divided by 2, that is 50. That is 50. Or that is 100 divided by 50, that is a 2 centimeters. I'm sorry for that. So 100 divided by 50, the scale, we measure 2 centimeters below. 2 centimeters below, 2 centimeters below. So from here, we measure 2 centimeters below. So 2 centimeters is up to that point. Yeah, up to that point. So 2 centimeters up to that point below. And that one will take us to, S. So this point is S. So this is S. And this is 100 meters, 2 centimeters. I forgot to put this one. For this offset, the first offset, that is here, this was supposed to be P. Was it P? No, not P. It was supposed to be T. It was 150. This was T. So this was T. Okay. Now after going to S, we go to the last one. The last one is from 500, 250 to R. So 250 to R, 250 meters, 250 meters. So what is 250 meters in centimeters? Just take 50 divided by 50. That will give 5 centimeters. So we are going to measure 5 centimeters now from this point. 5 centimeters. So 5 centimeters is there. So 5 centimeters. So this one is 5 centimeters, which is 250 meters. And that is R. That is R. Now after doing that, you can see now everything is clear. The offsets that are to the right S and T, they are below. Then P, Q, and R, they are above the baseline. After doing that, you can see there is a measurement that is remaining here. So remember the whole length, the XY is 12, supposed to be 12 centimeters. So we have 3 plus 1, that is 4. 4 plus 2.5, that is 6.5. 6.5 plus 3.5, that is 10. So what is remaining here is 2 centimeters. 2 centimeters or 100 meters. That is what is remaining. After doing that now, you join the offsets from baseline X, join to P, then from P join to Q, then from Q join to R, then from R to the last point, which is Y, using a ruler. So join that again, X to T, then T to S, T to S, so T to S, and then S to Y, like that. And you've done everything. That is what was required. You have used the scale, 1 centimeter represents 50 meters, and you have represented that. You have drawn the scale diagram. So once you've done that, now we can go to the questions. Let's go to the questions. Use the diagram above to calculate the area of the size of plantation in hectares. The area. How do you get the area of this figure here? We are going to calculate the area of each region. So we have this region. We call this region A. This is region B, C, D, E, F, and G. So we go to the first region A, because all these are shapes that you can get the formula, because you can see A is a triangle, for example. A is a triangle. So how do you get the area of that triangle? So for A, that is the area of the triangle, and the area will be given by a half times the base. The base is 150 meters. Use the meters on 50 meters times the height. The height is 3.5 centimeters. 3.5 centimeters. That one we said is equivalent to 175 meters. So 175. So when you multiply that, you get 13,125 meters squared. So it is 150 times 175, and then you divide by 2. Yeah, 13,125. Then you go to region B. For region B, that is a trapezium. How do you get the area of the trapezium? Half times the sum of the two parallel sides. The two parallel sides are 175 plus 150. 175 plus 150, then times the height. The height is this, 50 meters plus 125. So it is from this point to this point. So 50 plus 125, that will be 175. So we multiply these. So you have 175 plus 150 multiplied by 175, and you divide by 2. So this one gives 28,437.5 meters squared. We go to region C. So for region C, again, that one is a trapezium. So the same formula, half times the sum of the two parallel sides. The two parallel sides are 150 plus 250. 150 plus 250 multiplied by the height. The height is 175. You work out that. Again, you see, you get. So 150 plus 250 multiplied by 175, you divide that by 2. This one gives 35,000. This one gives 35,000 meters squared. We go to region D. Region D is a triangle, so that will be half multiplied by the base. The base is, you can see here, that is 100 meters times the height. The height is 250 meters. That will give 12,500 meters squared, which is very much okay. Now we go to the offsets that are below. We are through. These are the ones that are above. So the ones that are below, we have E. E is a triangle still. So this one will be half multiplied by the base. The base is 150 plus 50, that is 200 meters, times the height, which is 150. So see what you're going to get. So this one is 100. Let me confirm something here. So for E, that is the 150 plus 50. So that is 200. 150 plus 50, and then 3 centimeters. That's 150. So it is 200. 200 times 150. So when you multiply these will give 200 times 150, then you divide that by 2, you get 15,000. Then you give 15,000, get 15,000 meters squared. So for F, the trapezium, so it is half times the sum of the two parallel sides, which is 150 plus 100. 150 plus 100, then multiply by the height. The height will be 125 plus 175. 125 plus 175. That gives 300. It gives 300. So from here, 125 plus 175, that gives 300. So let us work out these and see. So we have 150 plus 100, and then we have multiply by 300, divide by 2. So get that is 7,500. That is 7,500. That is 7,000 meters squared. Now we go to the last one. The last one is G. So for G, this is a triangle. So it's a half times the base. The base is 100. You can see there is 100 times the height. Height again is 100. Base is 100. Height is 100. So this one, when you multiply, this will give 5,000, because this is 100 times 100, that is 10,000. So this will be 5,000 meters squared. So that is all. That is all now. After we've done that, we can now get the sum. We add everything now, total area, by adding everything here. So all the offset, these areas, 13, 125, you add everything. You add all these areas, the total areas of A plus B plus C plus D plus E plus F plus G. So we're going to add that. You be very keen. So 13, 125 plus 28, 437.5 plus 35,000 plus 12,500 plus, let me first get up to that point, 12,500 for these offsets. So for the offsets that are above, around I get 89,062.5. Then let me get the offsets below, 15,000 plus 37,500 plus 5,000. So that one gives 57,500 meters squared. Now after doing that, now we can get the sum. You add now the offsets above, total will be 89,062.5 plus 57,500. That gives 146,562.5 meters squared. Now to convert these into hectares, remember what 1 hectare is equivalent to 10,000 meters squared. So to convert these meters squared to hectares, you simply divide that by 10,000. When you divide that by 10,000, you'll get 14.6563 hectares. So that is the total area of this plantation. Part C, find the difference in the areas of either side of the baseline to the nearest hectare. That is why I got these, the area on either side. So the area above the offsets is 89,062. Below is 57. So you get the difference, 57,500 subtract. Now I think the bigger one is here. So 89, you can start with 89. So 89,062.5 meters squared. Subtract 57,500 meters squared. So when you get that difference, so 89,062.5 subtract 57,500. So you get this one is 31,562.5 meters squared. The nearest hectare, you divide this one by 10,000. This will give, and remember we are giving the answer to the nearest hectare. So when you divide these, because you got 31,562.5, this will give 3.1565. So that is the whole answer that you get when you divide these. Now to the nearest hectare, this will be approximately 3 hectares. Because you look at this number here, is a 0.1. So you round this one downwards. So to the nearest hectare, this will be 3 hectares. So that is how you're supposed to solve that question. Question 18. The figure below shows point A 612, B 93, and P -84. Point Q lies on OA such that 3OQ is equals to 2OA, while point R lies on AB such that AR ratio RB is equals to 1:2. The diagram is there. Part A, you're supposed to find the position vector of Q and hence the coordinates of point Q. Position vector of Q. So the position vector of Q means OQ. Vectors, position vectors are vectors with reference from the origin. So we get OQ. That is what will give us position vector of Q. Now looking at what you're given here, that 3OQ is equals to 2OA. So therefore, OQ will be, when you divide both sides by 3, you'll get 2/3 OA. So that is what is going to help us there from these statement here. You're given here 3OQ is equals to 2OA. So OQ will be 2/3 of OA when you divide both sides by 3. So OQ is equals to 2/3 OA. So this will give 2/3 OA. OA is 612. You write this one in column form. OA is 612. Like that. So this means 2/3 multiplied by 6. 2/3 multiplied by 6. That will give 4. 2/3 multiplied by 12. That will give 8. Like that. So that is the position vector of Q. And you're supposed to write the coordinates. So write the coordinates in this form. So this will be 4, 8. That is in coordinate form. So that is all about that part. The next question is the position vector of point R. The position vector of point R. So that means we are required to get OR. OR. So how do we get OR? OR will be given by OA. You want to move from O to R. So from O to A plus A to R. Like that. So you already know vector OA. OA is a 612 from the diagram there. This will be 612 plus AR. AR. How do we get AR? We are going to use the ratio that you're given here. This ratio you're given, AR ratio RB is 1:2. Like that. So that means AR will be a third of AB. A third of AB. Like that. And what is AB? We need to get AB. AB will be given by OB minus OA. We already have OB. OB is 93. Then OA is 612. So this will give 9 subtract 6. This will be 3. 3 subtract 12. This will be -9. So that is AB. So now when you go back to a solution having that AR will be a third AB. A third AB. So this will be a third AB. That is AR. We are giving AR now. AR is equals to a third AB. And AB, we already got AB as 3 -9. 3 -9. Like that. So this will give 612 plus a third times 3. That will give 1. Then a third times -9. That will give 9. No, a third times 9, that will give -3. I'm sorry. Give -3 there. So now you can add these. 6 plus 1, that is 7. 12 subtract 3. That will be 9. So that is the position vector. The position vector of point R. You can write it in coordinate, though it is not required. So R will be 7, 9. Like that. We go to the next question. QB, correct to 2 decimal places. So this means what? That you're required to get the length or the modulus or the magnitude. You see these 2 lines here. This means you're supposed to get the magnitude of QB. The magnitude of QB. So the first thing, we need to get QB. Before we get its magnitude, we need to get QB, vector QB. So how do you get QB? By getting OB, the position vector of B, subtract OQ. So already we have OB. OB is here. OB is 9.3. OB is 9.3. That. Then subtract OQ. OQ, we got it as 4.8. It is here in the first question, 4.8. So when we subtract these, we get 5. 9 subtract 4. Then 3 subtract 8. This is -5. So that is QB. Now to get QB, length of QB, or the magnitude, this is what we do. We take 5, we square that, plus -5. You also square that, and then you get the square root of everything there. So this will give the square root of 50. And the square root of 50 will be, correct 2 decimal places, 7.07 units, correct 2 decimal places. Then we go to the last question. Show that points P, Q, and R, P, Q, and R are collinear. So what do you mean by collinear? Collinearity simply means you're supposed to show that P, Q, and R lie on the same straight line. That is what you mean by collinear. So the first thing you're going to do is to form any 2 vectors using these, P, Q, and R, and I will form the vectors. So I'll form the vectors PQ, and using any, can form any vectors, and maybe you form QR, can take QR. Those vectors that you formed, for you to show that, or to prove collinearity, you have to show, number 1, that they are parallel. Those vectors are parallel by showing that they exist a scalar between them, or these 2 vectors are scalar multiples of each other. For example, you can say that you want to know the scalar that exists between them by taking PQ is equals to K, where K is a scalar, QR. So once you prove that there is a scalar, that they are scalar multiples of each other by finding K, you have proved that they lie on the same straight line. And then, as you will see, there is a common point Q on both of these vectors. So we get PQ. We get PQ first. So how do we get PQ? PQ is obtained by taking OQ, subtract OP. And because we already have OQ, OQ is there, choose a 4.8. Then OP is there, P is there, -8.4, -8.4, like that. So when you subtract these, 4 subtract -8, you get 12, and then this will give 8 subtract 4, you get 4. So that is PQ. Now let's get QR. QR, we get it by taking OR, subtract OQ. And this is what you're going to get, OR. OR, we got 7.9, is up there. Then OQ is 4.8. When you subtract these, you get 3.1. Now after getting the 2, now you have PQ is there, and you have QR is here. Remember these, you had said that PQ is equals to KQR. So PQ, which is 12.4, is equals to KQR. QR is 3.1, like that. So we want to find this scalar. 12.4 is equals to 3K. So if you get the same value of k in both cases, like for example, the first one is 12 is equals to 3k. 12 is equals to 3k. So what is k here? K is 4. You should get 4 below here. 4 is equals to k, because you can see that. So that means these vectors are scalar multiples of each other. They are multiples of each other. And that shows that they are parallel. So after doing that, now you can say PQ is equivalent to K, which is 4QR. So by doing so, you've proved that PQ is parallel to QR. You have proved. Then the other proof, when you look at these two vectors, PQ and QR, and say that QR is a common point on both vectors. You prove that. You got the last part. Find the ratio PQ, QR. Ratio PQ, QR. So what is going to help us here is this ratio that we got here. No, not the ratio, but the scalar that we already obtained. PQ. So we had said PQ is equals to KQR. And when you look at the diagram, still it will guide you. PQ, QR. So you can see these. You can join these. And we got that PQ. We got that PQ is equals to 4QR. So these alone will give you the ratio that PQ is equals to 4QR. So that means QR is a quarter of PQ. So a quarter means this one will be 1. This will be 1. So the ratio will be 4:1. That is the ratio PQ-QR. We are using this. So the ratio is 4:1. So here, the ratio, just a mark, the ratio is 4:1. As simple as that. Question 19. The diagram below shows a sketch of a curve y is equals to 2x squared plus 5. So the diagram is there. Part A, using the trapezium rule with 6 strips, estimate the area bounded by the curve. The lines x is equals to -2.5, x is equals to 3.5, and the line y is equals to 3. So there is the diagram. So the area that you are required to get, you need to identify that area bounded by this line. So you have x is equals to -2.5, and the other line there 3.5, and also the other line y is equals to 3. Y is equals to 3 is this line here. So the area that you need is actually this is the area. This is the area here, the area that is between here. So this is the area that you need. Now how do you get that area? You'll get the area under that curve between -2.5 and 3.5. Then you subtract the area below the line y is equals to 3. By doing so, you'll be left with the shaded area. So the area below the curve between -2.5 and 3.5, then subtract the area below the line y is equals to 3. You'll be left with that area. Therefore, you have to prepare the table of values in order to use the trapezium rule with 6 strips. So you need to know the height. So what will be the intervals? How do you get the intervals? So the interval, you're going to take 3.5. So to get the height, you're going to use 3.5, subtract -2.5. Then you divide by the number of strips required. So this will give 6 divided by 6, and the interval will be 1. So having known the interval, now you can proceed and draw the table. So let me draw the table of values. So you have x. So there is x, and then there is y. But now when you get the value of y, you have to subtract. You have to subtract 3. So y subtract 3. The reason why you're subtracting 3, because of this. You are getting the area under the curve, and then you subtract the area under the line. So you have to subtract 3 from the answer you get. So maybe I can do it like this. I can separate it like this. So you get y, and then the other one here will be y subtract 3 down here. So the intervals, you're starting from -2.5 and the height is 1. So from -2.5, the other one will be 1.5 because you have established that the height is 1. Then this will be -0.5. From -0.5, the next will be 0.5. And then the next one will be 1.5. So just adding 1, 2.5. And from 2.5, you have 3.5. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7 is okay. So now you substitute this value. You can see the intervals 1, 1, 1. So using this function to get the values of y, so you substitute. So when when x is equals to, for example, the first one, -2.5 squared plus 5, what will be the value of y? You are simply substituting the values of x here to this function because you want to get the area below that curve. So use a calculator to do this, and that will give you 17.5. That will give you 17.5 like that. You do the same for -1.5. So you're just substituting here. So -1.5. So when x is -1.5, what will be the value of y? And that one, you notice that one will be 9.5. That will be 9.5. To be 9.5, 9.5. So that is what you're going to do for all the others. So you simply substitute. I've already done that. So when x is -0.5, what will be y? Y will be 5.5. And when it is 0.5, again, this one will be 5.5. When x is 1.5, this will be 9.5. When it is 2.5, you'll get 17.5. When it is 3.5, you get 29.5. Now that is the area below the curve. We have to subtract the area below the line. So we have to subtract now 3. Y is equal y minus 3. Subtract 3 in each of these values of y. So we have y, subtract 3. So these will be 14.5. So you're taking 17.5, subtract 3, that is 14.5. 9.5, subtract 3, that will give 6.5. So the next one will give 2.5. This one will give 2.5 again. This will give 6.5. This one will give 14.5. This will give 26.5. Now these are the ones that you're going to use, the height that you're going to use. I'll denote this one by, these will be y0, y1, y2, y3, y4, y5, y6. So now after having those heights, how we use the trapezium rule. The trapezium rule is there in the 4-figure mathematical tables. So this is the formula for the trapezium rule. Half height, then the first height and the last height. In this case, the first is y0, the last is y6, plus twice the sum of all the others. y1, the middles, plus y2, plus y3, plus y4, plus y5, like that. So this will give a half. The height is 1, it is 1, then y0 is a 14.5, plus the last one there is 26, y6, 26.5, then plus twice the sum of all the others that are in the middle there. So you're beginning from 6.5 plus 2.5 plus 2.5 plus 6.5 plus 14.5, like that. So this will give a half, then 14.5 plus 26.5, that will give 41, then plus twice, 2 times the sum of everything there inside the bracket. That will give us, that is 6.5 plus 2.5 plus 2.5 plus 6.5 plus 14.5 multiplied by 2, that will give 65.4. And when you work out these, you get a half times 41 plus 65.4. These will give 53.2 square units. You get 53.2 square units. So that is the area using the trapezoidal or the trapezium rule. Now you're supposed to go to next question now because you're through with that. Calculate the difference in the area estimated in A above if the mid-ordinate rule with 6 strips is used instead of the trapezium rule. So use of calculating the same area but now using the mid-ordinate rule. So for the mid-ordinate rule, we use the midpoint of each of those strips. So we'll have to prepare another table here of values. Prepare another table of values here. I think that one is okay. So we want to extract the heights. So we have x, y, and then we have y subtract 3. We have to subtract 3, and I've explained why we're subtracting 3, because of the area below the line. So now how do we get the point that we're going to use? Now, because you're using the mid-ordinate rule, we are going to take the midpoint of each of these strips. Like the first strip, the midpoint is here. The second one, the midpoint is here. The midpoint is here. That is between negative 2.5 and negative 1.5. What is there? Negative 2. So we're going to take negative 2 there. Between negative 1.5 and 0.5, that one, the midpoint is negative 1. Then here, between negative 0.5 and 0.5, the midpoint of that strip will be 0. Then the next one, the midpoint of 0.5 and 1.5, what is between there? That is 1. Then between 1.5 and 2.5, the midpoint is 2. And then between 2.5 and 3.5, the midpoint is 3. So these are the ones that we're going to use. So negative 2, then negative 1 is here, then 0, then 1, then 2, and 3. So those are the midpoints. We use the same function. Y is equals to 2x squared plus 5. To fill the table, y is equals to 2x squared plus 5 to fill the table. So the first one is, you can fill the first one here. When x is negative 2, so you have 2. When x is negative 2, you square that, and then you add 5. So that one gives 13. So this one gives 13. So we are simply substituting when x. Let me just demonstrate using the first one. 2, first one is negative 2, that is squared, plus 5. That is what we have substituted in this function to get 13. Substitute negative 1. Substitute negative 1, you get 7. What about 0? You get 5. What about 1? What about 1? You'll get 7. What about 2? You get 13. What about 3? You get 23. Once you do that, now you subtract 3 to each of these. 13 subtract 3, you get 10. 7 subtract 3, you get 4. This you get 2. This one you get 4. This one you get 10. And this one you get 20. You're subtracting 3 from each values of y here. Now once you fit that table, now the mid-ordinate rule states that the area is given by height multiplied by the sum of the ordinates. Sum of the ordinates. So this will be height is 1. You can see the interval, negative 2 to negative 1, negative 1 to 0, the height is 1. Then the sum of the ordinates, you have 10 plus 4 plus 2 plus 4 plus 10 plus 20. So this one gives 50 square units. So you're supposed to calculate the difference in the area estimated above if the mid-ordinate rule with 6 strips. So you get the difference. Using the trapezium rule, you got 53. So now let us get the difference. So using the trapezium rule, we got 53.2. And then using the mid-ordinate rule, we got 50. So when you get that difference, the difference will be 3.2. 3.2. That is the difference. So that is how you're supposed to solve that question. And that is all. There are only 2 sections with 5 marks each. So that is how you're supposed to solve it. Question 20. The point P is the intersection of the perpendicular bisector to points A, negative 10, negative 1, and B, 2, 7, and it's also one of the vertices of a rhombus PQRS. Part A, obtain the equation of the diagonal PR in the form y is equals to mx plus c. So the first thing you're going to do is have a sketch of these rhombus and see where P lies. So I'll draw the sketch of a rhombus. And then P, show you where P is supposed to be. Should know the properties of a rhombus. All the sides are equal. This is just a sketch. So this is just a sketch. So P, name the rhombus P, Q, R, S. Now point P is the intersection of the perpendicular bisector to point, is points A and B, and is also one of the vertices of the rhombus. So because P is the intersection of the perpendicular bisector of point A and B, I'll put and B to lie somewhere here. So A and B, assuming that A will be there, and then B will be somewhere here. So we have A is there, and then B is here. So A is -10, -1, and then B is 2, 7. It's there. And then I can draw a line here, the diagonal of the rhombus. Diagonal of the rhombus there. And this point, because given that the point P is the intersection of the perpendicular bisector, sectors to point A and B, so this one should meet at 90 degrees, should be perpendicular, like that. Should be perpendicular, like that. So P is there, the center there. Now, having that, I think now we can proceed with the question. We are supposed to obtain the diagonal, the equation of the diagonal PR. So PR. So for you to get the equation of PR, you need either to have 2 points, or maybe 1 point and the gradient of that line. You have none. But it is possible to get a point. We can get this point P. Point P is the midpoint of AB. So we can begin by getting that. And how do we get the midpoint? Having point A, we let this one to be X1. And this one is Y1. So this one is Y1. Then this one is X2. This one is Y2. So to get the midpoint of AB, which is P, we are going to use this formula X1 plus Y1 plus X1 is a plus X1 plus X2 divided by 2, then Y1 plus Y2 divided by 2. That is how we get the midpoint when we're given 2 points. So X1 is -10, then X2 is 2, then you divide by 2. Y1 is -1, Y2 is 7, then divided by 2. So this gives P to be, this is -8 divided by 2, this is -4, and then this one is 6 divided by 2, that would be 3. So point P is 4, 3. So point P, which is here, point P, which is here, the center there, it is -4, 3. Now having that, for PR, remember we are getting the equation of PR. Now we have a point, we need to get the gradient. Now since this line is perpendicular, as you're given in that statement there, the first statement, line AB and this diagonal, they are meeting at right angles. So when two lines are perpendicular to one another, we know that the product of the gradient should be -1. If we let the gradient of M of AB to be M1 and the gradient of PR to be M2, since they are perpendicular, if I take the products of their gradients, I should get -1. So it is possible to get the gradient of AB. So gradient of AB will be given by change in Y. Just use this point, 7 subtract -1, like that, divided by change in X. Change in X, 2 subtract -10. So this will give 8. This will give 8 divided by 12. Now when you simplify this one by 4, 2, this will be 2/3. So the gradient of this line is 2/3. Thereby, using these, the gradient of PR, will therefore be -3/2. So that when you get the products of these gradients, you should get -1. They're perpendicular. Now we have a point and we have the gradient of PR. We have a point on PR, that is P. We have P. P is -4, -4, 3. And we can introduce another general point in order to get the equation on that line, that general point xy, and we have the gradient there. So using these 2 points, -4, 3 and xy, get the gradient. Gradient is change in y subtract 3, divided by change in x subtract -4, that will give x plus 4. That one should give the gradient, which is -3/2. Like that. So cross multiply here. 2 multiplied by y, that will be 2y. Subtract 2 multiplied by 3, you get 6, is equals to -3 times x, -3x. -3 times 4, you get -12. So you want to organize that in the form y is equals to mx plus c. So you have y is equals to -3 x, and then take these to the other side. These will give -6. That will give -6. The -6 or 3. So you have 12. Let me see. Because you want to divide, I'm dividing everything by 2. So this will be -6 divided by 2, -3. I think that one will be okay. So in the form y is equals to mx plus c, when you organize that, you'll get y is equals to -3x/2 subtract 3. So that is the first part of the question. We go to the second part. Given that x and y intercepts of the diagonal PR are the centers of the rhombus and the vertex R respectively, find the coordinates of R. So 2 things here, x and y intercepts of that diagonal that we've just obtained the equation here. So we can start with the x. The x-intercept will give the center of the rhombus. Then the y-intercept will give the vertex of R, will give the vertex R. That is the coordinates. So we start with the x-intercept, which will give us the center. And you know that at x-intercept, y is 0. So you simply take that equation, which is here, and then at x-intercept, y is 0. Substitute y with 0. So you'll get 0 is equals to -3/2x minus 3. Like that. So now get x. What will be x? You get x. So x will be given by, so this will be 3/2x is equals to -3. So x is equals to -3 times 2/3. So x will be -2. So this will give us the coordinates of the center. So x is, so the center will be, x is -2 and y is 0. So that will be the center. Then you go to the y-intercept. The y-intercept is supposed to give us the coordinates of R. The y-intercept. So at y-intercept, what is 0? X is 0. So simply take the equation of PR, of that diagonal PR, and substitute x with 0. So this will give y is equals to, x here is 0, so you get y is equals to -3. So the coordinates of R will be given by this. So x is 0, is there, and then y is -3. So we already done. We've done everything. We've obtained the coordinates of R. We go to part C. Point Q, which is -8, -4, is one of the vertices of the rhombus in A above. Obtain the equation of QS, leaving it in the form y. This is AX plus BY is equals to C, where A, B, and C are integers. Hence, state the coordinates of point S. So we are getting the equation of QS. So y is QS. You can see QS there. That is, let me draw that. QS. That is QS. And the properties of the diagonals of the rhombus, that is what is going to help us here. The diagonals of a rhombus intersect at 90 degrees. They are perpendicular. So with that, I'll be able to get the gradient of QS, because the gradient of PR will help us to get the gradient of QS, because those are two lines that are perpendicular to one another. So knowing the gradient of knowing the gradient of PR, the gradient of PR was -3/2. We got it from the first part, gradient of PR. So gradient of PR is equals to -3/2. So the gradient of QR will therefore be 2/3, because these are perpendicular and the product of their gradient should give -1. Now, having that, because we have the point which is -8, -4, we can introduce another general point on that line, xy, like that, and you will be able to get the equation. We have the gradient and we have these points. So how do you get these? Change in y subtract -4, that will give y plus 4. But change in x subtract -8, that will be x plus 8, should give us the gradient, which is 2/3. So we cross multiply here. 3 multiplied by y, that will be 3y, plus 3 multiplied by 4, that is 12, is equals to 2 times x, 2x, plus 2 times 8, that is 16. We reorganize the equation in this required format here. So in that format, we shall have, if I decide to bring everything to this side, we'll have -2x plus 3y, -2x plus 3y is equals to, we take this on to the other side, this will be 4, like that. Can multiply everything by negative to have 2x subtract 3y is equals to -4 if we multiply each term by negative. So it is in that format. We've given the equation in that format. AX plus BY is equals to C. Now after that, there's still another question. Find the coordinates of point S. The coordinates of point S. So how do you get the coordinates of point S? So here we have point S. So point S will be guided by, already we have the center. Remember, we have the center. We got the center from, there's a part here. Look at part B. The center of the rhombus was given by the x-intercept. So the center is here, -2, 0. So the center is -2, 0. -2, 0, like that. So, and we have Q. Q is -8. Q is -8. It is given down here, -8, -4. So since this point is the midpoint of QS, -2, 0 is the midpoint. So I will draw that line here. Let me draw it here. You can see it. So we have the center, we have Q, we have S. So we can let S to be XY because you don't know that. Then the center is 2, 0. And then we have Q. Q is -8, -4. So you know how to get the midpoint. We have written that formula there, that to get the midpoint, this point here, the center, to get the center, that is 2, 0. How do we do? We get x plus this is x1 plus x2. So x plus -8. Then we divide by 2. Then y plus -4. So y plus -4 divided by 2, like that. That is what is going to give. We have already written the formula for getting the midpoint in the other part there. So this will give 2, 0 is equals to, we can equate, let me equate the corresponding values of x. So 2 corresponds to x subtract 8, the x coordinates 2, like that. So this will give, when you multiply both sides by 2, you get 4 is equals to x subtract 8, like that. So x here, x will be given by 12. Is it 12? So x1 plus x2, x minus okay, divided by 2 is equals to, oh, this one is was it 2, 0? There's some correction there I need to make. The center, I think we got the center as -2, 0. I'm sorry for that. The center was -2, 0. Make a point of correction there. The center was -2, 0. So this was not 2, 0, but -2, 0, like that. So that now, this will be negative, me include that. So -2, you see that -2 is equals to that. So this, when you multiply both sides by 2, you get -4 here. So x will give, only so for x here, -4 is equals to x minus 8. X will be -4 plus 8, so it will be 4. And then 0 corresponds to y minus 4 divided by 2. So here we'll get, when you multiply both sides by 2, you get 0 is equals to y, subtract 4. So for this one, y will give 4, like that. And therefore, the point that is required, which is s is given by x is 4, x coordinate, and the y coordinate is 4. So we've answered the whole question. We've given the coordinates of point S. Also, we've given the equation of QS. The last question, part D, find the gradient of line RS. The gradient of line RS. So to get the gradient of RS, will be guided by, so when you look at the diagram there, you can see RS is parallel. Remember the properties of a rhombus, that is what you're using here. So this side is parallel to this side. So SR is parallel to PQ. SR, so SR is parallel to PQ. And that means they have equal gradients. So SR and PQ have equal gradient because they are parallel. So PQ, what is the gradient of PQ? PQ, I think we can get that, the gradient of PQ, since we have the points P and Q. So P is -4, 3. P is -4, 3. And Q is -8, -4. -8, -4. So when you get the gradient of PQ, it will be the same gradient for P of SR. So the gradient of SR is equivalent to the gradient of PQ because those two lines are parallel to one another, and parallel lines have equal gradients. So now the gradient will be given by change in y, which is -4, subtract 3, divided by change in x, -8, subtract -4. So this will give -7 divided by, this is a -4. So the gradient will therefore be 7/4. That is the gradient of SR and the gradient of PQ. So we go to question 21. The table below shows variations of velocity with time as a motorbike rider moves between 2 points. So there is time given there from 0 to 75 seconds, then the velocity meters per second. Part A of the question: on the grid provided, draw velocity time graph. Draw the velocity time graph. So that means on the y-axis, you're going to plot velocity, then on the x-axis, you're going to plot time. So the scale to use here, looking at the smallest in both cases. For the x-axis, we shall have time 0 to 75. So that one you can use 1 centimeter to represent 5. Then for the y-axis, we can use 5 as well. So let me draw the axis. Draw the axis. So those are the axes. So I have 0 here. The y-axis and the x-axis. So 0, 5, we have 10, 15, 20, 25, 30, 35, 40, 45. So for time goes up to 75, then 50, 55, 60, 65, 70, 75. The y-axis is the same, have 5, 10, 15, 20, 25, 30, 35, 40, 45. Can see that is okay. Everything can fit very well. Now we can plot time 0, 0. The first one, time in 0 seconds, velocity is 0 seconds. So we're starting from that. Then 10, 20. The next one is 10, 20. That one is there, 10, 20. Then the next one is 25, 25. 25, 25 is there. Then the next is 30, 15. 30, 15. There it is. Then 35, 35. 35, 35. There. 45, 40. 45, 40 here. 55, 10. 55, 10 is here. And 75, 0 is there. So now after plotting all the points, now we can join these points using straight line. So from 0, 0, that point, then the second one from here, there, then from there we go down, then from there up to that point. We're doing this using a ruler. That point, then down there, and then to the last point. So there we have the velocity time graph. And the y-axis, make sure you label these. This is velocity in meters per second, and then you have time in seconds. After doing that, we go to the questions. Use the graph, that is B, use the graph in A above to determine 1. The acceleration of the rider between 50th and 55th seconds. So how do we get, before we go to graph reading that, how do we get acceleration? Acceleration is change in speed over time. And change of speed, we get it by taking the final velocity, subtract initial velocity, that is the one that is going to give us the change in speed, everything divided by time. So we need to identify this change in velocity. What is the final velocity? And begin with that. What is the final velocity? The final velocity is, you're dealing with the 50th to 55th seconds. So for 55th, that is the one that is going to give us the final velocity. So 55th, when you read that, when time is 55 seconds, read the speed is 10. So that is 10 meters per second. That is at 55 seconds. Then the initial velocity we get it at a 50th second. So 50th second, what is the, when you go up 50th second to the graph, you notice that this one will be 25. We give 25 meters per second. At 50th second, the speed is 25 seconds. So 25 meters per second is what I mean. So that is at 50th second. So with this now, you can see we have the final velocity as 10 meters per second. Initial velocity is 25 meters per second. So now acceleration will be given by the final velocity, which is 10 meters per second, subtract the initial velocity, which is 25 meters per second, divided by the time taken. Time taken, remember this one is from 55 to 50. 55, that is the final time, minus 50 seconds. So this will give minus 5, 10 minus 25, that is minus 15 meters per second, divided by 5 seconds. And this will give a deceleration, which will be given by -3 meters per second squared. So that is how you're supposed to work out the first part. Now we go to the second part, the total distance covered by the motorbike in kilometers. Remember, when you get the distance here, we're going to get it in, because you can see you're given speed in meters per second. So when you get the total distance, we get that one in meters. So you have to convert to kilometers. Now, how do we get the distance? In a velocity time graph, the distance is obtained by getting the area under the graph. So distance is given by the total area under the graph. Total area under the graph. So that is what you're supposed to do. So when you look at the total area under the graph, we are going to divide that area into sections of shapes that we can get the area. I can take, for example, from this point, can draw a line there. This one will be, can call this area 1. That one is area 1. And then the other shape now from there, or let me just, instead of making it so small like that, can make it a little bit big and see, I can get it, can make it easier by expanding the triangle there so that I can have a bigger, this one is forming a triangle, so it is easier to get the area of the triangle. So can use this one, this can call this area 1. So this is area 1. Then from there, there's another trapezium I can form up to this point. I can form a trapezium, and this will give area 2. This will give area 2. And then from area 2, you can get area 3. So when I join it from this point, that one is also a trapezium, and also the other one here. And then there is another one here. So I'd like you to look at those sections. Then from there we have this one like that. So this one will be area 3, this one area 4, this one area 5, this one area 6, and this one area 7. You can see those shapes, we can be able to get the area of each of them, and then when we get the sum of all the areas of A1 up to A7, that will give the total distance in meters. Then we convert it in to kilometers. So we start with the first one, area 1. So we start with area 1. So area 1 is area 1. This one is a triangle. So the area is given by half times the base. The base is from 0 to 10, that is 10, times the height. The height is from 0 to 20, that is 20. So that will give 100 meters. Then we go to area 2. Area 2 starts from 10 seconds to 25. The area of a trapezium. How do we get the area of the trapezium? It is half times the sum of the two parallel sides. The two parallel sides are these heights. So from 0 to 10, these are from 0 to 20. And so these will be 20, can indicate this height. This will be 20. And then this one will be 25. And then the height will be 10 to 15. So two parallel sides is 20 plus 25. 20 plus 25. Then multiply by the height from 10 to 25. That is a difference of 15. So when you multiply that, you shall get 337.5 meters. We go to area 3. Area 3, you can see it here, small section here. So it's a trapezium still. So the height here is 25. Then the height here from this point, the height is 15. The height is 15. So the trapezium, half times the sum of the two parallel sides, you have 25 plus 15 times the height. The height is from 25 to 30. That is 5, a difference of 5. And that one gives 100 meters. That will give 100 meters. We go to area 4. We go to area 4. So area 4 is still a trapezium. Still a trapezium. We can get the height of this length here. You can see it here. So that height will be up to this point. This will be 35. 35. So a half times, to be a half times the sum of the two parallel sides. So we have this is 15 plus 35 times the height. The height is 30 to 35. So that is still 5. So when you get that area, that will give 125 meters. We go to area 5. Area 5 is here. So we have, this one is a trapezium still. So this height is 35 and then this one is 40. So area 5, a half times the sum of the two parallel sides, which is 35 and 40, times the height from 35 to 45. That is a difference of 10. So when you multiply that, that will give 375 meters. We go to area 6. Area 6 is still a trapezium. So we have that height as 40, and this other height here is 10. So a half times the sum of the two parallel sides, which is 40, plus a 10 times the height from 45 to 55. That is a difference of 10. So for area 6, this will give 250 meters. Now we are remaining with the last one. The last one here, area 7. So area 7, this is a triangle, a half times the base. The base is from 55 to 75. 55 to 75, that is a difference of 20. 75 minus 55, the base is 20, and the height is 10. And that one gives 100 meters. 100 meters. So now you get the total area. You add 100 meters plus 337.5 meters plus 100 meters plus 125 meters plus 375 meters plus 250 meters plus 100 meters. And this will give you the area, total area in meters, which is 1387.5 meters. That is in meters. So in kilometers, you simply divide this by 1,000. 1,000 meters is equivalent to 1 kilometer. This will give 1.3875 kilometers. So that is how you're supposed to solve that part. We go to the last one. Determine the time taken to cover the last 350 meters of the total distance. The last 350 meters. We can get this one from our working Xiam and actually from the diagram. Remember, the last 350 meters are here. 350. Look at these two. So 250 plus 100. That is giving 350. So we want that part. So 250. That is be given by area 6 and area 7. So area 6 and area 7. That is what is going to give us the last 350. This one. So just look at the time for these two area 6 and area 7. So the distance is from 45 seconds to 75 seconds. So beginning from here, so from 45 seconds to 75 seconds. So these two, area 6 and area 7, are the ones that are going to give us the last 350 meters. So because you are required to get the time, you simply get 75 seconds, subtract 45 seconds. That is the time. So 75 seconds minus 35 seconds. Like that. 35 seconds. So which will give 30. This is not 35. It is 45. So 75 subtract 45 seconds, which will give 30 seconds. You can see where I got this from. It is from these 2 points here, you can see. So 75 is there and 45 is there. So that is what gives the 350 meters, the last 350 meters. And that is how you're supposed to solve that question. Thank you. Question 22. 3 traders, Juma, Tom, and Mary, bought items in a wholesale shop. Juma bought 3 dozens of maize flour and 20 kg of sugar. Tom bought 45 packets of maize flour and 18 kg of sugar, while Mary bought 38 packets of maize flour and 25 kg of sugar. The prices of a packet of maize flour and a kilogram of sugar were 170 and 210 respectively. Part A, represent 1, the number of items bought by Juma, Tom, and Mary using a 3x2 matrix. A 3x2 matrix is a matrix that has 3 rows and 2 columns. You understand the order of matrices, 3 rows and 2 columns. So how do we get the 3 rows? This is how we're going to organize it. When you look at the first one, first statement, you have 3 people here because you have Juma, you have Tom, and Mary. So we can have the 3 rows, one to represent Juma, and then the other one to represent Tom, and the other one to represent Mary. That is how we have the 3 rows. And these are the figures that you're going to key in. So for Juma bought 3 dozens of maize flour. So let us see, 3 dozens of maize flour and 20 kg of sugar. I think this one should have been, something was omitted here. This is supposed to be 36. Sorry for this. This one is supposed to be 36, not 3. So can correct that in the question paper. It was meant to be 36, not 3. So 36 dozens of maize flour. So that is for Juma. So you're going to write 36. So this one, for the column, this column is going to represent maize flour. Maize flour, let me denote that one by F. And then sugar by S. Like that. So that now, the 3 rows are for Juma, Tom, and Mary. Then the 2 columns, one is for maize flour, the other one is for sugar. So 20 kg of sugar. Then for Tom, 45 packets of maize, and then 18 kg of sugar. Mary, 38 packets of maize flour and 25 kg of sugar. Now you can see when you represent it like that, where the rows are for each of these people. So you can now enclose that one to have the matrix that is required. So this is the matrix that is required. Remember, you're not supposed to include these. The matrix is only supposed to be what I've included there. These ones I was just putting in so that you can understand why I'm using the 3 rows and 2 columns. So the columns are for the first column is for the maize flour. Then the second column is for sugar. The first row for Juma, the second row for Tom, the third row for Mary. So that is the matrix. You formed it. It's supposed to be like that. Now we go to the next one. The prices of items bought using 2x1 matrix. The prices that represented here. So prices are only 2. Maize flour 170, and then a kilogram of sugar 210. Not as simple as that. That is a 2x1 matrix, 2 rows and 1 column. Very easy. Part B. Use the matrices in A above to determine the total expenditure incurred by each trader and hence determine the maximum difference between the traders. So now that we have arranged, we have the matrices. Just take 36. We are using this one, the matrix that is here. 3620, we are copying that. So we have 3620, 4518, and then 3825. Like that. And then you multiply that by the prices, 170 and 210. Get the expenditure. So that is the product we need to get. So you should understand how to multiply these. These are 3x2 matrix. And then this one is a 2x1 matrix. So of course the answer will be 3. When you multiply these, you'll get the answer to be 3x1. 3x1. That is how the answer will be, 3x1 matrix. So You know how to multiply these. So row 1 times the first column here, this column, so 36, 20, 170, 210. So these will be 36 times 170 plus, like this. Ensure that you are able to multiply these matrices. 20 times 210. That is the first row. So this row multiplied by this column. So we go to the second row. Second row where I have 45 times 170 plus 18 times 20, 18 times 210. We go to the third row, 38 times 170 like that, and then 25 times 210. So that is the matrix that we want, and the product is there. So now when you work out, you compute everything here using a calculator. For the first row, 36 times 170 plus 20 times 210, that will give 10, 320. Then the second, 45 times 170 plus 18 times 210, that will give 10, 430. Then the other one is 38 times 170 plus 25 times 210, will give 11, 710. Like that. So that means, remember what each of these represents. So this one was for the first one here. This one is for Juma. And then the second one was Tom. And then the third one is Mary. So maximum difference, because that is what you are required to get, the maximum difference between the traders. Maximum difference. So for maximum difference, you'll find which one will give you, which one are you going to subtract among the three, Juma, Tom, and Mary, that will give you the maximum, the biggest difference. You can look at this figure, look at the highest figure, for example. The highest, you're going to look for the highest minus the lowest. So the highest of all these is 11, 710. 11, 710. That is how you get the maximum difference, by taking the highest value, subtract the lowest. The lowest is 10, 320. And this one will give 3090. So that is all about that part. We go to the next part. So later in the week, the cost of maize flour decreased by 10%, while the price of sugar increased by 20%. Juma and Mary bought the same number of items as they did earlier in the week. Use matrix method to find the expenditure of each trader. So we have been given that the cost of maize flour decreased by 10%. So what is the new cost? The new cost of maize flour, because it has decreased by 10%, so the new one will be 90%. 90% of the original. The original, remember, was 170. The original was 170. 170. It is up here. 170. You are given it easier. Maize flour. Then sugar is 210. Sugar is 210. So this one will give 90%. So the new price will be 153. Then the new cost of sugar will be, this one increases by 20%. So it is 100 plus 20. So that will be 120% of 210. That is the original cost of 1 kg of sugar. This one gives 252. And after getting that now, we are required to use only two people here, not everybody. It is Juma and Mary, and you just extract that. Juma bought 36, was 36.20, and then Mary Mary 38, 25. I'm getting this one from the matrix that we had formed initially. It was here, Juma. So we are just using the two, Juma and Mary. Tom is not in there. So once we do that now, we multiply by the new price. The new price, that is 153 and 252, like that. So when you multiply these, the first row times this will be 36 times 153 plus 20 times 252. Then the second row is that column, 38 times 153 plus 25 times 252. Like that. So when you compute these, 36 times 153 plus 20 times 252, you get 10,548. Then the second row, 38 times 153 plus 25 times 252, that will give 12,114. So the question was use the matrix method to find the expenditure for each trader. So Juma, therefore, spent 10,548. And then we have Mary. Mary spent 12,114. So that is how you're supposed to solve that question. Question 23. The following distribution table below shows the wages paid per hour by a company to its workers. So the table is there, having the wages and the number of workers. Part A of the question. On the grid provided, draw a histogram to represent the information shown above. I have prepared a small table here because for this particular question, we are going to plot frequency density against the wages. So that is why I've prepared this, was for you to get the frequency density. Remember, frequency density is given by the frequency over the class width. So that is what I'm going to use here. I've keyed in the figures here for frequency, then the class width. I've given the figures there. So for the first one, our frequency density will be given by the frequency, which is 100 divided by 50. So that will give 2. So the second one, the frequency is 140 divided by 50. So let me divide these. So 140 divided by 50. 140 divided by 50. So that is going to give 2.8. The other one is 100 divided by 100. That is 1. Then the next is 220. 220 divided by 100. That will give 2.2. Then the next is 480 divided by 150. 480 divided by 150. That gives 3.2. The next is 80 divided by 100. And this will give 0.8. So that is the column that we needed. Frequency density. That is what will come here on the y-axis. So we have frequency density will be there. And then on the x-axis, we shall have the wages. Now, having got that, we can now go ahead and plot. Let me draw the axis. Don't need to draw the axis actually for these, because the lines are there. So the scale to use, look at the frequency density. The frequency density 2.81. So you can use 1 centimeter to represent 0.5. 1 centimeter to represent 0.5. So 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. Doesn't go beyond that. Then for the wages, I see the list is 50. Can use 1 centimeter to represent 50. So that can start from here. So 50. So 100, 150, 200, 250, 300, 350, 400, 450, 500, 550. And then we have 600. See, 600 is the last one. So you can stop at that point. Now from there, you can now plot the first class 50 to 100. The frequency density is 2. The frequency density is 2, 2.0. So you can plot that. So from here, so 2 is there. So just drop down. So that is the first bar. You can shade that, can shade it like that. So that is the first one. The second one, from 100 to 150, 2.8. From 100 to 150, that is 2.8. So 2.8. So from 100 to 150, 2.8. So 2.5, 0.6, 0.7, 0.8 is there. Then that one goes up to 150 like that. So that is the one. So you can shade it as well. Shade that as well. That is all about that class. We go to the next class. 150 to 250. 1. So that one goes to 150 to 250. 1. So this one goes to up to 250 at that point. Then 1 like that. You can shade that one as well. The next is a 250 to 350. 250 to 350. The frequency density there is 2.2. 2.2, 2.2, 2.1, 2.2 is there. 2.1, 2.2 is there. That one goes up to 350 like that. Then you can shade the bars. So that is the bar. The next one is a 350 to 500. 350 to 500, 3.2, 3.2. So 350 to 500. That one is 3.2. So 3.1, 3.2 is them. This one goes up to 500, goes up to that point. Then you drop down using a ruler. So we shade this one as well. So the next one, which is the last one, 500 to 600, that is 0.8. So 0.8, 0.8 is some of them. So that one goes up to the end, 600, like that, and then you can shade. So that is the frequency or histogram, not a frequency polygon. This one is a histogram. You've drawn it. So now the next thing that you're supposed to do, go to the question. So you have drawn that. The axes are labeled. So frequency, density, and then we have the wedges in the x-axis. So after you've done that, you get that one is supposed to give you 4 marks. So there's always a mark for the scale. Then for the bars, you get the marks there. The scale, you must be correct both axes. Now we go to the questions. After drawing the histogram, use the histogram 1 to state the class in which the median wage lies. State the class in which the median wage lies. So the first thing we're going to do is to get the position of the median. How do you get the position of the median? By taking half multiplied by the total frequency. Total frequency. So a half times the total frequency. Total frequency in this case is the total number of workers. So when you add the total number of workers, you will get, that is the total frequency here. When you add everything here, the summation of frequency, 100 plus 140 plus 100 plus 220 plus 480 plus 80, that will give 1120. 1120, that is the total frequency or the total number of workers. So the position of the median is half multiplied by the total frequency, 1120. So this will give you 560. So 5/60th worker is the one that is going to give us the median. Now, we need to have frequency density, a cumulative frequency column, cumulative frequency column. So I'll insert it here. The cumulative frequency that is going to assist us to identify the position of the median. So the first frequency is 100, then 100 plus 140, this will be 240. 240 plus 300, this will be 340. 340 plus 220, that will give 560. And then 560 plus 480. 560 plus 480, that gives 1040. Then 1040 plus 80, this will give 1120. So the cumulative frequency will help us to know the class where the median is. And where is 560? Where do we find 560? It is here. So this one is the median class. So the median class is 250, 250. Let me write it down here. So median class is here. So where we have 560, that is 250 to 350. Now, after identifying that, now we know very well that when you go to the graph, 250 is here. So the median is somewhere here. It is in between 250 to 350, somewhere here. So you need to know from 250 what will be the class width from 250 up to where we have the median 560. And this is how we're going to get it. The total frequency of the workers up to this point is 100 plus 240 plus 340. Okay, then we need this class here to know where we are going, exact place where you're going to draw the line. It is somewhere here. So we will take this frequency 100. So we have 100 plus 240. No, not 240, but I think I'm supposed to add the frequency that is 100. 100 is 100 plus, we are in the frequency, plus 140 plus 100. Then now this is the place where we need to, we don't know the exact number of workers who are here, and we want to get the class width. Remember, frequency density is given by frequency divided by the class width. So what about frequency? Frequency will be given by frequency density multiplied by the class width. So in this particular part, in this class, since we don't know, we are not sure of the class width, and that is what we want to establish here. From 250, we want to know the class width so that you can know what you're going to add to 250 in order to arrive to where the median class is, and that is where you're going to draw the line. So now after drawing the histogram, we go to part B, B1. State the class in which the median wage lies. The class in which the median wage lies. So how do we get the class? First of all, to get the position of the median, we take a half multiplied by the total frequency. This will give us the position of the median. The total frequency for this question, we can use the cumulative frequency to get that. Total frequency, that is the number of workers, total number of workers. You add 100 all the way to 80. That one will give you 1120. 1120, that is the total frequency or the total number of workers. So the position of the median will be half multiplied by 1120. So the 560th worker is the one that is going to give us the median. And now to get the class where the median wage lies, we are going to this table and I'm going to introduce a cumulative frequency. So cumulative frequency, this is how we get it. So 100, the first one frequency is 100. So add to the next 100 plus 140, that is 240. Then 240 plus 100, that is 340. 340 plus 220, that is 560. 560 plus 480, this will give 1040. Then 1040 plus 80, 1120. So now this one will help you to identify the median class. Remember, we said the median class will be located where the 560th student or the worker, 560th worker will be. So where is 560th worker is actually here, you can see, and that class is here. The class is 250 to 350. So the class, so median class is equals to 250 to 350. That is how we do it. So we first get the position of the median, that is a half times the total frequency. Once we do that, we got 560. Go to the table, identify where 560 lies, and you've noted that it lies in this class where you have 250 to 350. Let's go to the other question. Draw a vertical line to show the median wage. So how do you get the median from the frequency, from this histogram? How do you draw that line? There are several ways of doing this. How we use the frequency density to get that, the class width. So we've said that the class where the median will be found is 250 to 350. So it will be here. So from 250, we need to know what are we going to add in order to go up to where the median is. So from 250, so we shall get the frequency, the total frequency up to 250. So the total frequency up to that point is 340, because it is 100 plus 140 plus 100, that is 340. That is the total frequency. Total frequency from all these classes, I mean from here to here to here. So we want the total frequency up to 250, up to this class where you have the median wage. And you have taken 100 plus 140 plus 100, that is 340. Now we need to know now what frequency will be here? What frequency will be here to make 560? So remember, how do we get the frequency? From the formula, frequency density is equals to frequency divided by the class width. So what about frequency? Frequency will be given by frequency density multiplied by the class width. So we need to get the frequency that will be here, the frequency that will be here. And to get that frequency, we will get the frequency density of that class, the frequency density of that median class, which is, the frequency density of that class will be 2.2. See, 2.2 times the class width. We don't know the class width. And that is what is going to help us to know the position where you're going to draw the line. So we let the class width to be x. So these will give 560. So 340, the frequency up to this point, then plus the frequency that we don't know here, which we are calculating by the frequency density of that class multiplied by the class width. That will give 560. So from there, we will get 340 plus 2.2x is equals to 560. So 2.2x is equals to 560 subtract, this will give 560 subtract 340, that will give 220, and therefore x will be 220 divided by 2.2. That gives 100. That gives 100. So the class width is 100. So that means that now from 250, we are going to count 100. And you know the scale. The scale on the x-axis is 1 centimeter represents 50. 1 centimeter represents 50. So that one small square will represent, that is a 50. 1 centimeter represents 50. So 1 small square represents 10. 1 small square represents 10. So from here, we are going to count 10 squares. 10 squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these will be the position where we have 350. So from 250, the position of the median, you count 100. The class width will be 100. So from 250 here, I think I need to indicate this. So from here to this place, 100. That is what we have obtained here. So the line that you're going to draw will be here. So the vertical line will be here. I'll make it a little bit. So it will be here. That line will be there. That is where the median will be. The median will be there. So this is where the median, the line showing the vertical line showing the median, 350. Now, after doing that, now we can go to the next class, the next question. So the next question, part C, if the company workers report to work at 8 a.m. and depart at 5 p.m. with a 20 minutes tea break and 40 minutes lunch hour, determine the number of workers who earn 1,800 or less per day. 1,800 or less per day. So we need to get the number of workers who earn 1,800 or less per day. So they are working from 8 a.m. to 5. So 8 a.m. from 8 a.m. to 5 p.m. So those are 9 hours. That is 9 hours. And then you have to subtract in order to get the actual working hours. The break, they didn't work during the break. So you subtract that, 20 minutes plus 40 minutes. That is 1 hour. So when you subtract 1 hour, you remain with 8 hours. That is the active working hours. You leave alone the breaks. Now, after getting that, now we can get the number of workers who earn 1,800 and less. So number of workers will be given by, we take 1,800 divided by the number of the actual hours, working hours, that is 8. And this will give 1,800 divided by 8. This will give 225 workers. So 225 workers are the ones that are going to earn 1,800 or less per day. 225. Now, after getting that, 225. Now, let's go to part C. If the company workers report to work at 8 a.m. and depart at 5 p.m. with a 20 minutes break, this is a tea break, and 40 minutes lunch hour, determine the number of workers who earn 1,800 or less per day. So the workers are working from 8 a.m. to 5 p.m. So from 8 to 5 p.m., that is 9 hours. That is 9 hours. But those are not the active working hours. We have to subtract because there is a 20 minutes break. So subtract 20 minutes break because they never worked during this break. Then 40 minutes again. And you find this will give 1 hour. 9 hours minus 1 hour. These will be 8 hours. So the actual working hours will be 9 hours. That is the actual hours. So now having these, and you're required to determine the number of workers who earn 1,800 or less per day. This is what you're going to do. Now remember, the wage is paid per hour. So the wage will be given by the number of hours worked, which is 8 times the hourly payment. So you take the hours and then you multiply by the wage per hour. The wage per hour. That is the daily wage. So therefore, the daily wage will therefore be given by, when you take 1,800, that is the amount we paid, divided by 8. So the hourly wage will therefore be 225. 225. That will be the hourly wage, because we've seen the actual working hours are 8, and the amount we are determining the number of workers who earn 1,800 or less per day. So now having that 225, now we want to see how many workers will earn these. Let's go to the table. The table is going to assist us. Where is 225? 225 is found in this class, 150 to 250. So that means the workers who earn 1,800 or less will be 100 plus 140. And then some other workers that we don't know here. So 100 plus 140, 100 plus 140. So you take 100 plus 140 plus, because for the other class, remember for this class, we don't need up to 250. We need 150 to 225. We don't need the whole of these. We want up to 225. So from 150, to 225. So this one, you can see it gives a difference of, we only need the class width here will be 75. If you subtract 225, subtract 150, these will be 75. So that will be the class width that we require. We don't require all these 100 workers. We only require 75. So 150 plus 75, that is what you get, 225. So therefore the class width here will be 75. It will be 75. And remember, frequency is given by the frequency density times the class width. So the class width is already 75. So frequency density of that class, the frequency density of that class is 1. It is 1. You can see it is 1 here. So to get the frequency, the number of workers, these 75 work, this is 175. No, there is 75 shillings here. We need 75. So that is the class width, then times the frequency density, which is 1. So times 1. That will give the frequency, and this one should give 225. Should give 225. And this is going now to give us the number of workers. So 100 plus 140 plus 75. So this one will give 100 plus 140. This one will give 315. So 315 workers are the one who earn 1,800 or less per day. That is how you're supposed to solve that question. Question 24. The displacement S meters of a moving particle from point O after t seconds is given by S is equals to t cubed plus t squared minus 6t plus 8. Part A of the question. Find S when t is equals to 3 seconds. So to find S when t is equals to 3, you simply require to substitute the value of t, that is t is equals to 3 seconds, in the expression of distance S. So this will be S is equals to t, substitute that with 3. So this will be 3 cubed plus 3 squared minus 6 plus 8. So when you substitute these and compute these using your calculator, you're going to get 26 meters. So that is what you're supposed to do. Go to part B. Determine 1. The velocity of the particle when t is equals to 4 seconds. So how do you get velocity? Remember this, that if you're given displacement, you differentiate displacement to get velocity. You differentiate velocity to get acceleration. Downward movement, you differentiate. Upward movement, you integrate. So in this case, we are going to use S. So to get velocity will be given by, we differentiate S with respect to t. So differentiate t cubed, that gives 3t squared. Differentiate t squared, that will give 2t. Differentiate minus 6t, you get minus 6. So therefore velocity is equals to 3t squared plus 2t minus 6. As simple as that. Now we're supposed to get velocity when the particle when t is equals to 4 seconds. Now when t is equals to 4 seconds, you simply substitute these. So v is equals to 4 squared plus 2, 4 minus 6. Just substituting t is equals to 4 in that expression of velocity. And these will give velocity as, when you work out this using a calculator, you will get 50 meters per second. We go to the other part 2, the initial acceleration. The initial acceleration. How do you get acceleration? By simply differentiating velocity. So acceleration is given by differentiate velocity with respect to t. So expression for velocity is here. V is equals to 3t squared plus 2t minus 6. So when you differentiate that, you get 6t plus 2. So that is the expression for acceleration. A is equals to 6t plus 2. So now you require to get the initial acceleration. So at initial acceleration, time is given by 0 seconds. That is very important. At initial acceleration, t is equals to 0 seconds. So to get the initial acceleration, you simply need to substitute t with 0. So 6, t is 0 plus 2. And these will give 2 meters per second squared. So that is how we're supposed to do that. We go to the last part, the displacement s meters of the particle during the 4th second. The displacement s meters of the particle during the 4th second. So during the 4th second means from the 3rd second to the 4th second. That is what we mean by during the 4th second. So take the expression for displacement. S is equals to, is up here, t cubed plus t squared, t cubed plus t squared minus 6t plus 8, and 6t plus 8. So now to get the displacement of this particle between 3rd and 4th second, we're going to substitute a 4th second first when t is equals to 4. Then you get the difference when t is equals to 3. So we substitute t is equals to 4 first. So we get 4 cubed plus t squared, that is 4 squared, minus 6, this is 4, plus 8. Then we subtract, now substitute 3. Substitute 3, so t is equals to 3, this will be 3 cubed plus 3 squared minus 6, 3 plus 8. Now these will give you the distance or the displacement of the particle during the 4th second. That is between 4th second and 3rd second. So you just substitute t is equals to 4 in the expression for velocity, then subtract when you substitute t is equals to 3 in the same expression for displacement. So when you work out it like this and compute everything right in the calculator, you will get this one to be 38 meters. 38 meters. That is the first method. Alternatively, there's another method you can use. So alternatively, to get velocity, we integrate acceleration. You integrate acceleration to get velocity. You integrate velocity, get displacement. Since we want displacement, we are going to integrate velocity. We integrate velocity. So when you integrate velocity and the limit during the 4th second, from the 3rd second to the 4th second. So expression for velocity, what is it? 3t squared plus 2t, 3t squared plus 2t minus 6. So when you integrate velocity, you get displacement. So with respect to t, so this will give t cubed plus t squared minus 6t plus constant of integration, and then this is between 3 and 4. So when you substitute 4, you'll get this is 4 cubed plus 4 squared minus 6. Or you can drop c, since when you subtract it, you'll get 0. Then substitute 3. So get 3 cubed plus 3 squared minus 6, 3, like that. And you notice that this one will still give you the same thing. You still get 38 meters. So that is how you're supposed to solve that question.